Yes, pool pump motors with number 12 American wire gauge grounding conductors are required to be insulated. The reason for this requirement boils down to safety and the specific environment surrounding swimming pools. Grounding, in general, is a critical safety measure in electrical systems. It provides a low impedance path for fault current to return to the source, which allows overcurrent protective devices like circuit breakers or fuses to quickly trip and energize the circuit. This prevents dangerous voltages from being present on equipment enclosures or other conductive surfaces, which could lead to electric shock. In the context of swimming pools, the presence of water significantly increases the risk of electric shock. Water is an excellent conductor of electricity, and even a small amount of current passing through water can be hazardous or even fatal. For this reason, electrical codes such as the National Electrical Code, or NEC, have specific and stringent requirements for electrical installations in and around swimming pools. These requirements are designed to minimize the risk of electrical hazards and ensure the safety of swimmers and anyone near the pool. One of the key requirements is the use of insulated grounding conductors. The purpose of insulation on a grounding conductor is to prevent it from coming into contact with other conductive surfaces or objects that could be energized. If a grounding conductor is not insulated and it comes into contact with an energized surface, it could create a path for current to flow through the ground, potentially creating a shock hazard. In the case of pool pump motors, the grounding conductor is typically connected to the motor housing and other metal parts of the pump. If the motor develops a fault and the housing becomes energized, the grounding conductor provides a path for the fault current to flow back to the source. However, if the grounding conductor is not insulated and it comes into contact with a wet or damp surface, or with another conductive object near the pool, it could create a shock hazard for anyone who touches the pump or is in the vicinity of the pool. The NEC specifically addresses grounding and bonding requirements for swimming pools in Article 680. It details the requirements for the types of conductors that must be used, how they must be installed, and where they must be connected. One important concept in pool wiring is equipotential bonding. Equipotential bonding involves connecting all metal parts of the pool and the surrounding area together with a solid conductor. This includes the pool reinforcing steel, the metal components of the pool structure, metal fences, metal ladders, and any other metal objects that are within reach of someone in the pool. The purpose of equipotential bonding is to create a common electrical potential throughout the pool area. This means that if a fault occurs and a metal part becomes energized, all the other metal parts will also be at the same voltage. This minimizes the voltage difference between different metal objects, reducing the risk of electric shock. The size of the grounding conductor for a pool pump motor is typically determined by the size of the circuit conductors that supply the motor. The NEC provides tables that specify the minimum size of the grounding conductor based on the size of the circuit conductors. For example, if the circuit conductors are number 12 American wire gauge copper, the grounding conductor must also be at least number 12 American wire gauge copper. However, in some cases, a larger grounding conductor may be required if the circuit conductors are larger or if the motor is located in a particularly harsh environment. The requirement for insulated grounding conductors applies to all grounding conductors that are installed in or around swimming pools, not just those connected to pool pump motors. This includes the grounding conductors for pool lights, heaters, and other electrical equipment. The insulation on the grounding conductor must be rated for the voltage and temperature conditions of the installation. It must also be resistant to moisture, chemicals, and other environmental factors that could damage the insulation. When installing grounding conductors in or around swimming pools, it is important to follow all the requirements of the NEC and any local electrical codes. This includes using the correct type and size of conductor, properly terminating the conductor, and ensuring that the conductor is properly protected from physical damage. It is also important to have the installation inspected by a qualified electrical inspector to ensure that it meets all the applicable requirements. Failure to comply with these requirements could result in serious electrical hazards, including electric shock and even death. In addition to the requirements for grounding conductors, the NEC also has specific requirements for ground fault circuit interrupters, or GFCIs, in swimming pool installations. GFCIs are devices that are designed to detect even small amounts of current leakage to ground. When a GFCI detects a ground fault, it quickly trips and energizes the circuit, preventing electric shock. The NEC requires GFCIs to be installed on all circuits that supply power to equipment in or around swimming pools, including pool pump motors, lights, and heaters. This provides an additional layer of protection against electric shock. When selecting a GFCI for a swimming pool installation, it is important to choose a device that is specifically designed for use in wet or damp locations. These GFCIs are typically enclosed in a waterproof or weatherproof enclosure to protect them from the elements. It is also important to test the GFCI regularly to ensure that it is functioning properly. The NEC requires GFCIs to be tested at least once a month by pressing the test button on the device. If the GFCI does not trip when the test button is pressed, it should be replaced immediately. In summary, the requirement for insulated grounding conductors for pool pump motors is a critical safety measure that is designed to protect swimmers and others from electric shock. By following the requirements of the NEC and any local electrical codes, and by using properly installed and maintained grounding conductors and GFCIs, it is possible to minimize the risk of electrical hazards in and around swimming pools. This is extremely important, especially in an area where water and electricity are in close proximity. Remember that specific local codes may vary or have additional requirements. Always consult with a qualified electrician to ensure full compliance with all applicable codes and regulations for your specific location and installation.